give you just the details about it, like what we are going to cover and all those things, and what is a simple data modeling overview. Because this is going to be a session which will last for around 12 hours. So I would like to start this class as a first class and then get started with it, because our target is to complete this somewhere between 12 to 15 hours. What are the topics that I'm going to cover, and which tool I'm going to demonstrate, and what are the things that you learn as part of this? So all those things I'll explain you, and thereafter we'll have a question hour. I mean, like, what is your expectation out of this class and everything? And then once it is done, we'll get started with the actual class, and we'll start with the data modeling overview. Okay. See, in general, when it comes to the data modeling, right, it is more important for ETL developers who are actually going in as more than 6-year-old. Then they'll probably ask you to do the data modeling as well. And there are a lot of opportunities on the data modeling side. When you want to go in as a data modeler, you need to know the different concepts, and you need to also know at least the minimum tool, I mean, one tool to do that. So as we know, like, what I will start in this course is that we will send you this course curriculum after today's class. So the first one is we'll go and understand about the data modeling overview, like what we are going to. Yeah, I'll keep you guys, all of you on the mute, because to avoid the noise. So one is that first we'll talk about the data modeling overview, and the second one is your data modeling life cycle. So basically, how does a data modeling life cycle starts in any project? How we are going to do that? So in the data modeling overview only, I'm going to talk about the different things, like what is an entity, and what do you mean by an attribute, and what do you mean by the relationship, like how do you define a relationship between the entities, and different other things we'll discuss. And in this only, we'll also talk about the normalization of a data. What is normalization, and what are the different normal forms that we have? Uh, um, like, we'll take the some 2 or 3 examples, um, 2 or 3 examples, and understand how to normalize them to the third normal form or fourth normal form. How do we achieve that? And we will understand the different normal forms is like 1NF, and basically the 2NF, 3NF, all those things we'll understand. And we'll also talk about the BCNF, Boyce Codd normal form, and also the fourth normal form, what you see. So that is the normalization what we talk about. And once the normalization and everything is done, then we'll talk about the data modeling life cycle. Then we will understand the overview of entity relationship modeling. So which is nothing but the ER modeling, which we are going to talk about. As you guys already know, like, entity relationship modeling is actually used for OLTP applications. And we'll understand about ER modeling in a high level overview. And then we will design a data model for one of the domain. Basically, I would like to choose that as a design a ER model for insurance companies. Let's say for an insurance domain. Let's take the insurance as our domain specific, and we will understand what are the requirements of an insurance company, and when they want to define a transactional application, how do they want to design all those things. We'll design a ER model for a insurance company. So basically, on the insurance side, we'll have different subject areas, namely, like, we'll have a claim center, I mean, which handles the claims and everything, and one subject area which will talk about the policies which it will issue, and one subject area which will talk about the billing related thing, like how do you actually collect the premiums from the this one. So we will design an ER model. So when we are designing an ER model, we will understand basically how can we use Erwin. See, all of you might be knowing already that there are a different data modeling tools which are available in the market. So which is like, we have tools like Power Designer, Erwin, ER Studio. How does Erwin community edition will work? See, basically, the getting a license edition for Erwin will be very difficult for us. So basically, we are going to understand on the Erwin community edition, which can be defined for a 25 tables. So defining a 25 tables data model is free, absolutely free in the Erwin. So we are going to understand how to define the logical model, physical model in the Erwin, and how to do the forward engineering process, reverse engineering process, how do you enable the indexes, how do you create the partitions, how do you create the triggers on within that, how do you enable the validation rules, what are the models, everything that we are going to discuss in an Erwin. So basically, the Erwin is a data modeling tool this which we are going to use. So I would say that learning one data modeling tool gives you the confidence to work on any other data modeling tool, because the concepts and everything that what we see is going to be the same. It does not vary from one data modeling tool to other data modeling tool. So once you are good with this, let's say once you are good with the creating a entity relationship model, any one of the module. So either for a claim center or a policy center or a billing center, I prefer to go with claim center because I have a good grip on the understanding of how the claim life cycle works here and everything. And when you talk about once you are done with this, since I think most of you are from the a data warehousing background, then I will be actually going more on the dimensional modeling techniques. So basically, what are the facts, dimensions, and everything. So if you're already aware of what are the slowly changing dimensions and what are the fact tables and everything, then probably I'll directly start with a sample data model or a sample use case model, which we have. If you're not aware of it, we'll discuss about what is a data warehouse and data mart, and what is the dimensional modeling is all about, how do you define the dimensions and the fact table. Then we will design a star schema, snowflake schemas, maybe one star schema and one snowflake schema will define through the Erwin. We'll understand how to design the dimensional model in case of this. So how do we use that with respect to that? So that will define a design a dimensional model with respect to that. So once we are done with it, then we'll talk about the different other things in terms of a partitioning. Like basically, how does a partitioning will help you in a data warehousing environment, and what kind of partitions that you define, and all these things is there on my agenda. Like these are the things that we are going to discuss predominantly, along with the theoretical concepts like a normalization and the ER modeling. Mainly, I'm going to run on the defining all these things on the Erwin. So when you talk about the Erwin, like we will see how to define a domains, how to define attributes, how to create the super type entities, subtype entities, and how to resolve the many to many relationship. Each and everything that we are going to talk within the a data modeling class. So this is basically I'm expecting this to last for 12 hours, and this is what something that which I have in my mind to do that. And along with this, maybe if you start applying for a, let's say for a ETL developer job or a data modeler job, so what are the different things or data modeling interview preparation, like what you need to do and how you want to define all those things, that also we are going to discuss as part of this. So these are the specified contents which I have. Basically, I would like to hear from you. I mean, in case if anybody is looking for beyond this for understanding on the data modeling side, so I would like to incorporate all those changes, and then we will get started directly on the data modeling overview. First, to give you insight on the data modeling overview, like what do we go about and what do you need to do. So anybody has anything to add here along with these things, along with these contents, whatever I have listed down here. If you have anything, probably I'll incorporate them, or if you have any other expectation also, probably you can share it with me. Then we'll get started with the actual class or actual syllabus in the today itself. So I'd like to hear from you because I see that most of you have joined today, and I want to understand what is your expectation. So let me just unmute you. If anybody has anything, probably you can share it, and based on that, we'll go forward. Right. So basically, okay. So okay. So validating the data model, yes. So I can even add that as part of this validation of the data model, maybe within the Erwin, or when you actually do the design the ER model. This is just a high level thing. And when you are looking for a validation of the data model, yes, we can even add that how to validate the data model, or how to um, the integrate this data model with other data modeling tools also, that also we can probably see that. I mean, maybe the Power Designer or something. Okay. What else? Anything else? Right. So I hope, okay, so let's get started on the data modeling overview. So let me just give you the better insight onto before we proceed with, yeah, cardinality and all those things we'll understand in the relationship, like what is a cardinality and how do you represent a cardinality between the tables. What do you mean by cardinality and what is relationship, like one to one, one to many, all those things we'll discuss within this only. Okay. So from tomorrow, we'll actually get started with actual syllabus, but let me just try and give you what is a outline of what is a data modeling is all about. So what is data modeling? Any idea? Like when do you do the data modeling, or like see, basically whether you're talking about a transactional application or whether you're talking about an analytical application, means if you're defining a database tables for a transactional application, or if you want to define a tables to store the data in a warehouse, a data modeling process is actually followed. So data modeling is more like the process of designing the, the process of designing the tables and columns and data types. So all those things, when you are designing a tables, columns, data types for a particular application to store the data, that is called as a data modeling process. So data modeling process is always essential one, whether you are designing a data model for a transactional system or for an analytical system, whatever you have. So when you talk about the data model, so data model is basically when you talk about this is a pictorial representation of, the when you are actually representing the tables, columns, and everything in the form of a diagram, that is called as a data model. So as a data modeler, see, most of the time when you go to the highly process oriented projects, you'll have a separate role uh, in anything. I mean, whether it is a warehouse or this thing. So you'll have a separate role called as a data modeler, who actually designs the data model. So what is the responsibilities of a data modeler is that uh, data modeler needs to understand the requirements based on the application that you would like to design and translate those requirements into data storage units, that is nothing but your tables. So we'll actually translate all those requirements and define the tables for storing the data. So that is the high level responsibility of a data modeler, whoever it is. So this data modeling process is very complex because you need to understand the requirements and represent all the requirements appropriately within your data model, whatever you would like to define. So basically, when you talk about this data modeling process, you need to understand about the various definitions and everything before we talk about the data modeling process. In general, let's talk about what are the steps that happen in a data modeling life cycle. So first thing is that you need to understand the requirements. So requirements is nothing but you need to gather the requirements from the business. Let's say, let's take a simple example for today's class. Okay, maybe some retail application or a banking application. We'll take it, and then we'll understand the requirements. We'll list down the requirements and translate into a data model. So gather the requirements and understand the requirements from the business, whatever it is, whether it is a retail or whether it is a, you know the whether it is a retail or a banking or anything. So you can define it. So the second one is about the, you need to define the conceptual model. Like conceptual model is nothing but representing all your requirements in the form of a representing all your requirements in the form of an entities and representing the relationship between the entities. So is done in the conceptual modeling process. So once you're done with the conceptual modeling, the third phase is more like a logical modeling, which we have, and the fourth one is about the physical modeling. We convert all the logical modeling whichever is there into the physical modeling, and the fifth one is more like a creating a database scripts and all those things. So create DDL scripts and whatever is required for you to create the tables in the database that we are going to define. So these are the steps that which happens in any data modeling life cycle. I mean, data modeling life cycle. So the output of, or the end product of the data model is that ultimately you have to create whatever the tables that you want to store the data, those tables in a particular database. See, all your data modeling tools are compatible with all the types of databases, relational databases like Oracle, SQL Server, Sybase, and DB2. But the community edition which we are going to work, that is your Erwin community edition, I think it is compatible with only Oracle, SQL Server, and DB2 and Sybase, not with the other databases. But if you go for a licensed edition, I think it is even compatible with the other. It is even compatible with other type of databases as well. So let's try to create a simple data model for a time being. I just want to give you the overview about it. But tomorrow I'll go in detail and understand what is an entity is all about, what is an attribute is all about, and what is a relationship and everything. So basically, when you talk about the entity, what do you mean by an entity in general? What is an entity is all about? Any idea? What do you mean by an entity?
Entity is an object.
Yeah. So you can call, yes, entity as an object, or you can call it as a data object, which has the group of attributes. So basically, entity can be your place or a thing or anything. I mean, that entity is an object which has the group of attributes, or you can call an entity as which represents the multiple instances of data. I mean, let's say when you talk about the customer, when you talk about a customer in any business, we'll have a different set of a customers which is there. So entity is also something that which represents the instance of data or a multiple instances of data that is called as an entity. So again, there are different types of an entities. We'll go in detail about it, like in the we'll go in detail. And another one is about the attribute. So attribute is nothing but a property of an entity is called as an attribute. So when you say an attribute, um, property of a entity which we call, that is called as an attribute. Suppose let's say we have a, when we talk about the example for an entity as a customer, so customer, if you consider this as an entity, and the attributes are like your customer name, customer email address, and phone number of a customer, SSN number of a customer, or all these details are called as an attribute. So basically, when you understand the requirements in a data modeling lifecycle, you actually convert all these requirements in the form of entities. You will identify the different entities in your module or a subject area, and then you actually define the different entities. Okay. So, and in between the entity, you can also represent a cardinality. So I'll give you a definition clearly tomorrow in the tomorrow's class about the cardinality. But for now, let's understand what do you mean by the relationship. So whenever you represent a relationship between the two entities, so it is basically the relationship will be of three types. Either you'll have a one-to-one relationship between the two entities, and you'll have a one-to-many relationship between the two entities, or many-to-many relationship between the two entities. So how do you express the relationship between the two entities? That also we'll discuss now. So I'll try to come up with a simple conceptual model, and how we can convert that conceptual model into a logical and physical, that I'll just explain you in brief when you talk about. So let's say you know what is an entity and what is an attribute and what do you mean by the relationship. So these are the very three important things that you need to understand. See, I'm not focusing more on the normalization part here now. So we'll discuss that in detail probably starting from the tomorrow's class. I mean, in a sequential manner. So since it is a more like a demo class, I would like to give you the overall idea, like how conceptual model is created basically based on the requirements. Suppose let's say when you want to define a data model for a particular application, first and foremost thing is that you need to understand each and every requirement, what type of data that they want to store, and what are all the different information that they want to store, and how they want to store each and everything, you need to capture it. So let's take a simple example and create a sample conceptual model, and how can we convert a conceptual model into a logical thing and everything. So there are different types of an entities. I'm not talking about them like super type entity, subtype entity, identifying entity, all those things. We'll talk about this probably. I have a presentation, but I don't have it right now to show you. Okay, so let's try to prepare a sample diagram, and then we'll convert that conceptual model into a logical and physical. How do we do that? So I'm just trying to explain you what do you have in case of a data modeling life cycle. So what will happen? So suppose, let's say you're building a data model for a retail application or a retail industry. So what are the, I mean, what is a generic requirement of the retail industry? Let's say, let's talk about an e-commerce industry. Like, how does the e-commerce industry works? Basically, there will be a website, and the people will come and buy the products, and they actually add it to the cart, and they purchase the products. They pay the amount through the credit card or through the internet banking or different other ways of payments they do. And within a e-commerce website, you'll basically have different categories of products, and different products you'll have, and all those products will be purchased by the customer. So overall, if you understand of an e-commerce industry, so what are all the different entities that you can think of? What are the different entities that you can think of in a retail industry or an e-commerce application? Let's think about your Amazon or eBay. Like, what are the different entities that you can think, or what are the different entities for which you have to store the data? You can also use your chat window to reply back to me. So yes, so the first one may be about the customer, right? So we'll talk about the so let's say we have this as a customer table. What we have, let's say this is my customer. Yes, you do have even an inventory and all those things. Yeah, we'll come back to that. Okay, so the another one which you call this as an order, which you have it as an order, what you see. And what else will be customer, order, and product, which you can think of a product. Product is also another entity. What we have, product is another entity. And for each customer, you might be storing the different addresses, basically the present address or a permanent address, or the shipping address or a billing address, all those things. Even the address also you store. So what else you can think of? See, each product will be supplied by the different categories, or it's supplied by even by the different vendors. The different vendors might supply the product. So who is the vendor that is actually selling a product which we have? So basically this is another is about this is a vendor what we have. So the next one is about the payment. So what are the different payment methods? And that also you can think of, like payment types or a payment or a mode of payment, how it is done. So all these things we can even treat that as a, probably I'll represent it here, which is very small. And let me call, okay, customer will have a different options. I mean, we can even have that as a payment type or a payment methods what we have. So that is your payment type is also one entity what you can think of. Okay, what else? What else is another entity you can think of in a retail industry? So date is not actually an entity, but when it comes to dimensional modeling, we treat the date as an entity. But date as a separate entity we think. But yeah, shipping or billing, what are the modes of shipping? Like, how do you would like to ship the order? So shipping is probably you can consider how do you ship the order and how you want to ship it. So I'm not going, I mean, the representation becomes complex here in the paint window, so I'm not taking that. So let's try to finish. So supplier and vendor both are same. I mean, like okay, supplier is somebody like who ships the product. Yeah. So even that way, you can even do that, but I'm not going in much details about it. Okay, let's, yeah, you can even consider those things like, the shipping or who supplies, or like who are the carriers who supplies your products, like whether it is a FedEx or all those things, that also you can represent. So carriers or the courier suppliers or carriers, and you'll also have that as a supplier, or you can call it as a shipping methods or a shipping types, how you would like to do that, whether it is airway or all those things you can define. So let's try to understand how we can define, or now how can we represent a relationship between the multiple different entities. So see, the conceptual model, when you talk about, right, the conceptual model, whenever you see the convert identifying the entities and representing a relationship between the entities, that is called as your conceptual model. Okay, how do we do that now? So basically, let's say I would like to create a relationship between a one entity to the other entity. So how do we do that? So can one customer, okay, so we talked about the relationship in a different way. So whether it is one-to-one relationship or one-to-many relationship or a many-to-many relationship. Now, basically, when you talk about an order, one order can have multiple customers. Is it possible that one order can be placed by the multiple customers? So one order can have multiple customers in it? No, it is not possible. But one customer can have multiple orders, isn't it? Is it possible or not possible? One customer can have a multiple orders, which is possible. So when you represent the relationship between this to this is called as a many to one, which is nothing but one customer can have a multiple orders. It's like a one to n. So the cardinality is like a one to n cardinality, what you say. So we'll go in detail about it. For now, let's understand in terms of a relationship. So one order can have a multiple products. Possible? One order can have a multiple products. In one single order, I can buy two mobile phones and two accessories, whatever it is. So we call the order with respect to the product. So basically, this is going to be your one to many. And one order, one product can be a part of multiple orders. True or false? One order can be a part of multiple products. Yes, it is possible. I mean, you can buy Samsung mobile phone and I can buy a Samsung mobile phone. So this representation is called as a many to many representation. Okay, one vendor supplies the multiple products. True. One vendor or one retailer supplies the multiple products, and one product can be supplied by multiple vendors as well. True or false? So what about the relationship between a product and a vendor? Is it one to many or many to many? Yes, it is possible. I mean, like you might have a multiple retailers who can supply the different products. So in an e-commerce industry, when you think of, yes, it is possible. Like multiple vendors can supply the same product to you when you do that. So this is like a many to many relationship. Now, one customer can have a multiple addresses, or one address can be shared by multiple customers. So what would be the relationship between this and this? What would be the relationship between a customer and an address entity? So it's going to be again a one to many relationship.
One to
See, yes, so one to many relationship. So one customer can have a multiple payment options, and this payment is something that the payment is something that, see, your each payment might be associated with the customer as well. See, let's say I have a payments like a customer can pay through the credit card or internet banking or by using a debit card or the different options which I have. So payment type, payment number, date, start date, end date, all those things when you want to store it. So one customer can have multiple payment options which they store it in that. Um, One customer can have a multiple payment options which they can use and then pay the payment. So if you see, actually, when you go to Amazon and all, you can actually save all your credit cards. Maybe one from ICICI Bank, another from your maybe Standard Chartered or from Barclay or a Citi card. I can store all my 10 credit cards which I have into that. So when you say one customer can have a multiple payment types, yes, it is possible. So this is your payment type. Basically, we need to have two things here. So one is you have a payment type, how it is there. So basically, when you think of customer to a payment, it is like a many to many, I would say. So how many will you agree with me whether it is many to many or one to many? But it is not the same credit card that they use. When I talk about the payment type, so here I'm calling this entity as a payment type. So basically, one customer can have a multiple payment types, which is like they can pay through the credit card, all these things which they have. So if you see, this is your many to many relationship, I would say. Now, order every order will be associated with a payment. So that order and order payment, you can have it in a separate entity or you can just represent in the same way. So this is a general way of understanding your requirements and calling them, I mean, understanding your requirements and converting those requirements into a entity relationship model. So when you talk about a conceptual model, it is nothing but you understand the requirements, what kind of data that they want to store, how you want to translate and everything, and you represent a relationship between that. So that is called as your conceptual modeling. So when you represent the entities and the relationships together, and if you're preparing a diagram, something like this is called as an ER diagram, which is called as a entity relationship diagram. So which is called as a entity relationship diagram. So this is what you're going to achieve then by using this. So this is your ER diagram. So the output of the conceptual model is always about the representing the entities and the relationship between that. So that is called as your conceptual modeling or this. Now, once you see, basically your data model will be very big when you're representing for an e-commerce industry. So maybe for order management, we'll have a separate module, and for managing the payments, you'll have a separate entities and everything. So on an overall, I just represented just by understanding a simpler requirements and translated it. It is not that we'll have only these many entities. For a retail industry, you might have a n number of entities. So just for categories, storing the categories and the products itself, you'll have a separate data model just for a product. And just for a customer, you'll have a separate data model. So just for a different payment types, you'll have a separate model. So just for a order, I mean, order, shipping and everything, you'll have a separate module which will be there. So we'll understand that how we can actually classify the data model for one particular industry into the different data models, and how we can actually correlate them into a single data model. So that we will discuss with respect to that. So this is your simple entity relationship diagram, what you prepare when you, I mean, what you have for a conceptual model. Similarly, from the conceptual model, we'll again start with a logical model. So in the logical model, what you do is you'll identify the entities, unique identifier to, I mean, unique identifier to define a identify an entity, something like order ID and customer ID, address ID, payment type is could be the payment ID and all those things. And when you talk about the product, so which is like a product ID, vendor ID, and all those things, we identify. See, basically, in case of a logical data modeling, we normalize the entities. We normalize the entities up to third normal form or a fourth normal form. So we normalize all the entities and the logical modeling, and we prepare the logical model most of the time in the third normal form or a fourth normal form. So for time being, we are not going into what is a normal form and how to apply the different rules and all, and what is the need of normalization and everything. So I'm just saying that it will be always normalized, and always in a logical model, your many to many relationship will be resolved. Many to many relationship will be resolved and stored into this. So that is about your logical modeling, what you see. So once you're done with the logical modeling, then we convert the logical model into a physical model depending upon the database that you're using. See, your physical model is going to be different. Your physical model is going to be different for different type of databases, because the data type across the databases will be different when you choose that. So data types will be different. So we'll convert that we'll convert the logical model into a physical model, and we define the validation rules, everything in the physical model, and we convert the physical model into a final DDL scripts and pass it to the DBA. So this is I mean, I just gave you the overall data modeling life cycle. So all these defining the conceptual model, defining the logical model, resolving everything that I'm going to show you in a Erwin, that is your community data addition, which we have as a 9.6 version, which we have. I think that is this is the latest version we have. You can download and save it. So currently in my machine, this is probably expired. So I'll actually download it and recreate it one more time. And from tomorrow, basically, I would like to start from the actual syllabus. So first, one or two classes will have a complete theory, which you will be understanding about the different types of entities, how you resolve the I mean, what are the different types of entities, relationships, attributes, cardinality? How do you express each and everything? But from the next time, next onwards, we'll take directly the sample example for an insurance and identify all the insurance related entities, and we create a data model for a claim center. Then we'll convert the same claim center transactional model into a analytical model. So how we can prepare a analytical model for a claim center, that also we'll discuss. So in between these, we are going to understand each and every minute and granular level topics, whichever is required. So those things also will be discussed as part of it. So by your morning, I'm going to send you what are the contents that we are going to cover in a detailed way. Probably how much time also it will take, that also I'm going to send it to you. So this is something that which I wanted to give you the overall idea, like what we are going to learn as part of the training. That's it I have for now. So if you have any probably questions, I can answer them for today. And from tomorrow, we'll start with the actual class. So as I said, like I'm going to send you the complete details of your syllabus and send it to you. Right. So any questions that you guys have for me, or you wanted to add anything? Okay. What is the schedule is basically we have classes from the 7:15 expected end time. So probably we'll have for an hour every day. Probably to I'm giving you the time in the Indian timings. So mostly we'll finish it up by the 8:15. If not, 5 minutes extra. 8:20 something will wind up. That's it. 8:20 a.m. So that's it. Not more than that. So that would be the schedule, and it'll be on the weekdays. Yeah, it'll go for 12 days. Yes. So weekdays only. It'll go for 12 days. From now, let's say we are starting from tomorrow. It could go for 23, something like that. Somewhere between this. It'll go for 23. Right. So any other questions? Yeah. So basically, probably you can ping all your email address and the phone number so that it will be easier for us to follow up with you uh, and to discuss the your expectation and everything. So starting, if you could ping your email address and the phone number, that would be easier for us to follow up with you. So I want all of